Welcome to another episode of WaveFEA tutorials. This is your host Mac, and today we're going to talk about WaveFEA's ability to import analysis data from Autodesk Moldflow. This was primarily done in order to use Advanced Material Exchange, which is a part of the powerful Helios PFA Autodesk Moldflow software. In this tutorial, we're going to see how exactly the Advanced Material Exchange, here on referred to as AME, can be done. With the integration of AME, WaveFEA can map results from Autodesk Moldflow analysis onto a structural finite element analysis mesh to accurately represent fiber orientations or residual strains. Any material nonlinearities or failures can be precisely identified using the robust Helios PFA solver in the early stages of the design. Let's jump right into the tutorials. We begin with remeshing the model with a mesh size of 2 mm, which can be done by setting the element size as 2 under the mesh settings. We will also have to disable the reduced integration for the C-tetra elements. This can be done by entering the parameters section in the WaveFEA tree, searching the tetradot, and setting it to off. Once this is done, we can now divide the load. This can be done by going to nonlinear setup and defining the number of increments. Let's just say 100. Set the intermediate output to all and click OK. As we have added the enforced motion, we now need to constrain the motion in that particular direction. This can be done by opening the constraints menu and constraining the phase to TY direction by selecting the TY checkbox under the coordinate system and clicking OK. Once the constraints are defined, the next step would be to generate the NAS file by right-clicking the empty space on the WaveFEA tree and clicking on the Generate NASTran file, which will be displayed on the screen. Save this file as coupon.nas, which will be imported into the AME environment. Now that we have completed our Moldflow simulation and have set up an initial NASTran input file, we are ready to pair the models with the Advanced Material Exchange. Open the AME app and click on the Path Mapping menu. Locate the plague.sdy file under the Choose Study section. We can see a preview of plague.sdy file. Let's now select the structural file, which we created a while ago in WaveFEA and had named it as coupon.nas. We might get a notification stating that the models are not aligned. Click Yes to align the models. Enter TY as 20 mm and TZ as minus 38.1 mm and click OK to align the models. Now that the models are aligned, we can define the environment, which can be done by clicking on the Select Environment option under the Materials tab. Select the first row in the tension table data, with the temperature as 23 degrees and strain rate as 0.01. Click OK to confirm. We are now ready to plot the map. Click on the Mapping Suitability Plot option, which will provide an indication of how well the Moldflow results are mapping to the structural model. As we can see from the mapping suitability plot that most of the models appear green, indicating there is sufficient mesh refinement to map the results. The threshold scale can be further varied to identify areas where potential mesh refinement may be necessary. Now that all the prerequisites are defined, click on Map Results to map the fiber orientations to the structural model. This might take a little while. The progress can be seen on the status bar. After the results have been mapped to the structural model, go to the Settings menu and enable the Rupture under the Rupture tab. We are ready to export the results to our FEA program where we can analyze our models. Click Export to Structural Package, select the directory at the desired location or create a new one. Name the file as coupon_AME and save it. The progress of the file saved can be seen in the status bar. A notification will pop up indicating the export of the structural file is complete. Click OK to proceed further. Now open SolidWorks and edit the analysis. Go to the Options tab, set the large displacements to off, check the Import Structural Model under Advanced Material Exchange, locate the NAS file coupon_AME which was earlier exported by Advanced Material Exchange, generate the NASTran file and verify if the MathXM card is available. Now we are ready to solve the analysis in NASTran. As we have defined the number of increments to be 100, the solver will take time to solve all the models. Let me just skip the video to the 100th increment. Once the solution is complete, a notification would pop up indicating the process is successful. Click OK to proceed further, and we should be able to see the AME results in the AME section. A total of 7 AME results are available to view on the contour plot. The results can be viewed by editing them on the WaveFEA tree under the Subcases section. The result data for all the 100 increments will be available. Select the result data as AME and choose different types to view results for various increments. Monitor the matrix tangent elastic modulus as the tensile displacement load is applied to the coupon. Notice how the values in the notched gauge region are much lower than the remainder of the coupon. This indicates a large amount of plasticity or material softening. Switch to the solid AME damage state result to examine the rupture state of the composite part. A value of 1.0 indicates that the composite has not failed, whereas a value of 2.0 indicates that the composite has failed. By monitoring the damage state throughout the load history, we can see that the failure progresses very quickly between the load increments of 0.6 and 0.61. To give a brief summary, in this tutorial, we have learned how to use Advanced Material Exchange to map fiber orientation results from Autodesk Moldflow to structural model using WaveFEA. Thank you so much for joining us today. This is your host Max signing off. We will be back soon with more features and updates from WaveFEA team. Thank you.